Hello, everyone, and thank you for joining us for this session of the Technomatics Virtual User Group, our community conversations. As you can see from the slide there, our topic for today is how to create a simple crane control. I'm your host. This is Taryn Blake, Community Engagement Program Manager for the Siemens software community. And as you probably know, our speaker for our series is Mr. Stefan Bangsel. He is a freelance simulation expert in this space for many years, completing hundreds of projects and training sessions. He's done several with us now, last year and moving into next year. And he's also published 5 books on plant simulation and can almost always be found in our Siemens PLM community forums. So we're very happy to have another session today. And our agenda, or the big steps for today's demonstration, is using the Cranes and More library, basic structure of a crane control, and loading and unloading parts. So as always, we are live today. Stefan's here and myself. You also will be able to ask questions at the end of the presentation. You can raise your hand. There's a button in the middle of your screen, I believe, at the top middle. You can raise your hand and we'll be happy to take you off mute to ask questions at the end. And of course, you can always use the chat feature. So that's it for the introduction. Stefan, feel free to take it away.
Hello to our today's webinar. We will create a crane control, not the most simplest like in the demonstration of the example in the small examples collection. Little more complicated, but you can change this as a crane control for more complex projects. Okay, I share my screen. We start with a blank screen. First, we need to add the Cranes and More library to our class library. And this you do with Manage Class Library. And you need to select the Cranes and More library. You see here in 2404, there are not so many libraries left. Siemens has reduced the number of libraries, and you have a lot of stuff in the Cranes and More library now. And here in the Cranes and More library, you'll find the multi-portal crane. This we will use today. But here you also find a 7-axis robot, the gantry loader, and the lift. And then there's a vehicle lift. We will create a lift later in another webinar. Today we want to use the multi-portal crane. Just drag one crane into your frame. Double click opens a dialog for adjusting the crane. We need to change the length of the runway to 40 meters or 120 feet with 15 or 45 feet. And here you can also set a bigger number of portals. You will see then simulation will adjust the crane, depend on your settings. I want to have a height of the portal of 10 meters or 30 feet. And there's here an overhang. You see this crane is here going over the rails here. I don't want to have overhang, so I change this to 0. Okay, now I have a crane. You have several settings for the trolley and for the hook. but I don't want to change here the settings. You can check this by yourself. So, and now it's the question how to use this this portal crane. I want to make a very basic example. I switch to planning view. All elements that the crane should lift needs to be inside the crane rails. Otherwise, you get an error message. So I want to have a source, okay, and then one station for start. And you see, you don't see the names of the 3D elements. So I change the class of station, added 3D properties, and I want to see the caption, the name here. So it's easier to follow. This I want to, I changed the name to start. And this start station has a cycle time of 1 minute. And then the production flow is going to 3 different stations, M1, M2, M3. For instance, like this here, you have several processing stations under a crane, M1. M2. And then I want to finish this with a train. And the production flow is, it comes from start. All elements have to go to start, and then it goes to M1 or M2 or M3, and then to train. And I want to change the processing times to a uniform distributed time here between 5 minutes and 20 minutes, so that we don't have a fixed order of calls here. Same for M2, uniform distributed processing time between 5 and 20 minutes. Same for M3. And you can connect the source with the start station. So you have a very basic example for stationary processing production. And now we need to control this. And you have an example in the small examples collection where you control the crane by exit controls. I don't want to do this here. We can have several calls for the crane at the same time, and so I want to have a table where I can place the order, and then the crane will process this table of first come, first serve, for instance. There's only one possibility how to do this. And so I want to have a table jobs, for instance. And in these jobs, I want to have two objects, columns. And switch on the column index. And I need the information from to where should go the transport from station X to another station. And this information I need for each job. No priorities here, only the crane should only process the jobs from line 1 to line X. And I want to have a method add job to create one job in this table. I want to have two parameters here, source and destination. Both type object. And then I just write a new row into jobs. I need to specify the starting point of my write command here. This is 1 and jobs item +1, the next free line. And I just write source and destination. Into my table. You can also write, for instance, a time so that you can optimize the crane movement to avoid long waiting times. And so you can, for instance, prioritize make a priority based on the waiting time. But if you want to do this, then you need to record also the time when you start this job here. Okay. I want to control the crane with a central control. And if you know my examples, I have a lot of methods with the name doJob. This job runs in an endless loop like a PLC control. And so we need to call it for the first time in the init method. And after one job is done, then this control will call itself again and again. And so we can be sure that this doJob is running only once and not dozens of time, only once in parallel. But we need to call this method in the init method first. And I need to delete my jobs. And we need, if we stop the simulation somewhere in between and the job is not done, then maybe the crane could have a state different from waiting and idle. And so I want to I call end sequence of the portal, and so I have for sure the state idle for the crane. We need it later. Maybe we need to change the order of the bolts here. But Siemens has changed a lot of in the multi-portal crane, the last versions. So maybe you don't need this line here. Jobs delayed. Okay. Now I need to have two different. We need to program two different things. One is how the stations are calling do job, and the second is we need add job, and we need to program the do job method of the crane. For instance, if we have start here, the exit control of the station, then we need to wait until one of this station is empty. And then we have a problem that it takes time. If we start a new job, then the crane maybe is already busy, and it takes time until he comes and take this part here and move it to another station. And during this time, it can happen a lot of changes here, and so you need some kind of reserve mechanism. When the transport itself can take long time, and you can have one transport underway and the another part is already executing the exit control here, then you need some reserve mechanism. Siemens has created such a mechanism in 2404 for the Walker, but you need to install some same kind of mechanism for the crane, for instance. And I will make it using a variable. I name it on the way to, and it should be an object, and the initial value should be void. And if I start a transport in direction of M1, then I set this variable to M1, and then I need to check, okay, M1 is empty, and no transport is on the way to M1. And so I have a condition for starting a transport from start to M1. Same for M2 and M3. And so I need exit control for start. This is also new in 2404. If you change the name of a method, then it looks if this method is already somewhere, but it should not come here. So you can drag this method to start and start with include this or enter this as an exit control. Exit control front is okay. And here I don't need add move. Here I need to select the target for my transport. So, and wait until M1 is empty. And on the way to is not M1. Or, and then we can copy and paste. M2 is empty and no transport on the way to M2. Or M3 is empty and no transports on the way to M3. And then I need the conditions again. If this condition is met here, if this condition is met, then my target is M1. And again, copy and paste. Is M2 empty and no transports on the way, then it's M2. The same again for M3. And for the impossible case that there is else, then debug. We have a look on it, but if you wait for one of these conditions, then one of these conditions should be true. So then we need to add a drop. From here to target. And we set on the way to target to avoid a double move to the same station. This is one of the problems many have, that you have somewhere in your simulation a second transport to already occupied station, and then the crane cannot move the part on the station, and then you get really chaos in your simulation. And so you need to avoid this with 2 steps. Make a reservation and check the occupation of the station before you start moving. Okay, this is the exit control of the start station, and we have no add move because we now wait for the crane to do this. For the station M1, M2, M3, I only want to move the train, and so I have a very simple exit control. One for all. Exit control M. 9. And this is the exit control of M1, M2, and M3. And here I only want to add a job from here to train. This may be much more complicated if you have several other options where to go, and but here I need to look on my clock here. I only want to go to train from all stations here. I think it's very important to separate the logic in the production here, as a where going from here to here, from there, and so on, to separate the logic inside the production, the flow of production, from the crane itself. The crane has only to do a job to transport a part from a source to a destination. That's all. And so you can simplify the controls in a very good way, and you can make some standard programmings, because the crane itself, the crane movement, is standard. And Plan Simulation already has implemented a lot of standard methods here for the crane to move a part from A to B, for instance. I want to make it a little bit more extended here. I don't want to use the comfort methods out of the box. Okay, let's write the crane control. I need some variables. Start. I need target. And I want to have a variable for the portal itself. For the portal, there are several methods and ways to get this. The portal it's a transporter on the multi-portal crane. So you can read it with cont, but there's also point portal 1 and 2 as attribute. So you can also take portal 1 to address the first portal if you have several. Next, we need to wait for a job. And this means, in our case, wait until jobs by them greater than 0. I need to read start and destination, start and target, or source and destination from the jobs table. Start is in the first cell, target the second column, first row. And then I delete with cut row the first row. And then I need to move the portal to the start. And there's a method here for the portal. It's move to object. It moves the portal itself and the trolley to the position of the object, but it doesn't lower the hook at the same time, because in many cases you cannot do this in this way. You cannot move the hook at the same time like the portal. If you have a 3D portal, then you can do this because it's more stiff in the construction, but you cannot do this with a 10-meter high portal crane. And so we need to move the first two axes, and then we need to wait until the crane is on its position, and this we can read with the state of the crane. The portal change the state to waiting if it's finished with the movement. So we have wait until now, wait until portal point state is waiting. And a little smaller. Then I want to move the hook down to a height of 1 meter, and so we need to lower the hook by 9 meters. The height of my portal crane is 10 meters, and so I need the hook 9 meters. Portal. And this will make with move hook, and I need to set the final position. And then I need again and again here, this is wait until portal state waiting, to wait for the end of this movement. Then I move the part. Normally you need to wait a certain time that you need to assembly the part to the hook, and then you can move the hook, move the part to the portal, and then you need to move the hook again to lift up the hook, and this is here. Zero, the position 0 is on top, near to the portal itself, near to the trolley, I want to move it to 1.5 meters, for instance. If you run in feet, then just write feet at the end to make it in feet. So, and then I go to target. It's like here, it's like start the same, move to object, target. I need again to wait until the portal has reached its destination. Then I move to down. Have it already here. Position 9 or what else you have. If you want to place it on the button on the floor, then it's move hook 10. Then normally you have to wait a little time, and then for the point move the target. Then move hook up. You see, it's only a handful of commands you need to control the crane. And in the end, you finish the job. And this is done with portal point and sequence. This will set the portal to idle. If you want to wait for this, if you want to wait for the end of a job, for instance, if you use the method transfer part or transfer mu, then all the steps here are inside this out of the box method, and at the end the state will be idle, not waiting, will be idle, and then you need to wait for idle instead. If you make several movements like here, then you can wait for waiting, and you need to end your sequence by yourself. And then the job is end. It's finished, and then you need to recall the method. Execute no call chain. So you don't create a lot of unfinished method calls. If you only call execute, then each method will wait until the next the previous method is finished, and so we have a lot of parallel calls. If you call execute no call chain, then this method will be finished, and the next method instance will be called independently from this method here. Yes, several steps, but these steps are the same for each transport of the crane. And the logic, it's only now in the exit controls of the stations here to control the flow through the production. Okay, let's have a try. M1 is finished and it transports part to train. Okay, that's it. Do you have questions? Yes, one standard question is here. If you have more than one crane, how to avoid collisions? And there's a collision control here because today it's still a transporter here, and so the transporter can collide. But in reality, if you have heavy equipment, then you cannot collide the cranes. Then you have normally some strategy to avoid collisions without colliding. And so you need to look in reality what are the strategies to avoid colliding. It could be, for instance, a place where the cranes are sharing parts, where one crane is placing the part, another crane comes and takes the part from there. And so we can avoid blockages and collisions. Another way would be to block certain areas that when you move into an area, you block this area and you need to release it if you move outwards this area. And the most complicated is that you follow the crane a little bit until he is outside of your area. But this means thousands of lines of programming. So this you need to check with the programmers or with the technique in reality, what they use for strategy, and then you can build it here into the simulation. There was one in the chat here. Can we use Technomatics to create value stream mapping? Yes, there is a third-party library for value stream mapping. If you go to Manage Class Library, there's a library for value stream mapping. It's here, Manage Class Library, and here you have a licensed library value stream mapping. And you need to ask your Siemens representative to buy it. It's here. There's a number here, license TN 75096, and this is the catalog number from Siemens products. Okay.
So right now on your screen, you should be seeing a screenshot of a web page that is the Plant Simulation Virtual User Group. So it's part of the community forums for Siemens software. And the link that you see on the screen, actually, you can click on it. It will take you to that page directly. The illustration, or the animation rather, that you see is showing you how to subscribe to that page, to follow. And once you click follow, to choose every post for email notifications. That is because the only thing that we post there are recordings of these sessions, registration links for the next sessions, and then questions, which you are welcome to post about the sessions that have already occurred. So if you do watch one of these videos, or you've been to a session, you have questions later, you can look for the recording of the session, and always mention Stefan there. We have some other experts as well who should be able to help you get your questions answered. So with that in mind, the next sessions, you also may see those on the screen. The next few topics coming up Wednesday, October 30th, is creating a 2-lane turntable. After that, November 13th, conwhip control. And then November 26th, which will be on a Tuesday, random worker behavior. So again, those registration links will show up in the forums at that URL on the screen. They will definitely be there. The next one for October 30th, the link will be there by Friday. And the same thing, the recording for today will be there by Friday as well. And so this URL, that is that link there, Siemens Software Plant Simulation Virtual User Group, you can click there right now. And that is the forums where that will be available on Friday. And then again, the other hyperlink is to Stefan's profile in the community. And that is also how you might mention him if you have any questions when you watch the recording.
And we will also post the model there in the forum.
Yes, yes. So that's good. Got a couple of thank yous in the comments. Appreciate that. Okay, well, it seems like everyone has their questions answered. Yeah, we've got some applause there. So we don't need to keep you any longer. You can definitely find us in those forums at the URL that is available on your screen. And thank you, Stefan, for another great session.
Thank you. Goodbye.
Bye, everyone.